Very good morning. In this session, now I am going to discuss about neodymium based lasers. In last class, I already discussed about solid state laser. In that solid state laser, the first type of the laser is ruby laser. In last class, I already finished that ruby laser. In this session, now I am going to discuss about that is neodymium based lasers. The neodymium based lasers there are two types of neodymium based lasers are there. First one is neodymium ND YAG laser and second one is ND neodymium glass laser. First is neodymium YAG laser. Neodymium YAG laser means ND means that is neodymium, YAG means that is YAG means yttrium aluminum garnet laser. Okay na? Yttrium aluminum garnet. Now this is first type of laser in neodymium based laser, and second type of laser is neodymium gas laser. Okay. Now I am going to neodymium YAG lasers. YAG, that is yttrium aluminum garnet laser. Here this neodymium yttrium YAG laser is actually that is a 4-level laser. 4-level laser. Here neodymium ND YAG laser is also a solid state laser. ND YAG laser is also a solid state laser. Here in this active medium, what is that active medium? Neodymium that acts as the active medium. Neodymium is a active medium, and YAG that is acts as the host medium. That is the host of the particular to host the neodymium ions. Now we are using this yttrium aluminum garnet mixture. What is this yttrium aluminum garnet? YAG means that is actually one type of that is a crystal. Okay, na? Crystal. Is it YAG means why we are using this YAG? To excitation of, for the when the laser action is going on there, for the excitation of the ions of neodymium ions, we can place some amount of the concentration with we can adding the some amount of the concentration we are adding YAG concentration we are adding in neodymium ions. Okay, na? For the excitation or for the excitation purpose we are of neodymium ions we are using this YAG concentrations. Okay. Now ND neodymium based laser ND for actually how the output we are getting in ND YAG laser, that is either that is continuous output or else pulsed output we are getting in ND YAG lasers. Most probably the continuous output most of the output we are getting in ND YAG laser, that is continuous output, and the emission of ND YAG laser, ND YAG laser is at the wavelength of at the place of what is the population inversion is occurred from the energy level from the E2 to E3 to E1. At the place the emission where at the length of that emission is 1.06 micrometers, and here the pump band of excitation that is within the range of from 0.81 micrometer to 0.75 micrometer, and where the spontaneous emission is going on there when the atoms or the ions are it falls down from the energy level E4 to E3, the laser transition is there. The ions are stays within at the very short duration of the time. Transition at the time approximately that is equal to 550 microseconds only. It can stay the ions, they can stay at the higher level, that is E4. It can stay at the higher level E4 at 550 microseconds only. Next, here Why we are preferring here? It has lower threshold of oscillation than the ruby laser. NDYG lasers are lower threshold oscillation than the ruby laser. Output energy in the order of output energy up to we are getting 100 joules per pulse. 100 joules per pulse. Actually, here it is where we are using this NDR laser. Generally, we are using the trimming purpose, drilling purpose, and scribbling purpose, and welding purpose. We are using this NDR lasers. Now, here, now I am going to that how it is the construction of NDR lasers and working of NDR lasers and application and advantages and disadvantages of NDR lasers. Yttrium, YAG means that is yttrium aluminium garnet. Here, yttrium aluminium garnet. Here, this yttrium aluminium garnet we are using that crystal on the crystal. It is the best host for that neodymium ions. Okay. India YAG offers very low threshold. Why we are choosing this YAG only? Because of it has very low threshold and high gain. And main advantage of it is good thermal and mechanical properties. India laser, that is the India crystal rod that is having in India YAG crystal that is having good thermal and mechanical properties, and it is very hard and isotopic crystal. Can be drawn and fabricated in rods of high optical quality and operation. How we can operate it? Either by using the continuous wave. How we are output of the India laser output is in the form of continuous wave or the pulsed mode of output. Okay, next. Now, the efficiency about 10 times as compared to the ruby laser, as compared to the more than 10 times of the ruby laser efficiency is more than of this NDR laser. And drastic waste reduction as compared to the previous one, that is the ruby laser. Here the weight of the particular NDR laser is very less. Okay, replaced with, that's why we are using this NDR laser. We can military range finding purpose and other applications. That means biomedical applications also we are using. Used in semiconductor industry for laser trimming, silicon scribbling and marking, and drilling purpose we are using this same NDR laser. For continuous or very high repetition rate operation, crystalline material provide higher gain and greater thermal conductivity. Okay, this is about main introduction part of NDR laser. And what is this active center? What is the active center we are using in this NDR laser? When we are coming to the construction, the active center that is neodymium ion. A rare neodymium ion is active center, and host material is YAG, that is yttrium aluminium garnet. Okay, na? Emission, where the emission is we are getting, where the where the population is there, we are getting some emission. The emission within the range of 1.064 micrometers. Okay, na? In NDR lasers, ND3 ions takes place in yttrium ions. Why? Because for the excitation of NDR lasers, we require some amount of the YAG ND3, some amount of the YAG ions. That's why to pull the ions from the lower stage to higher state, now we are using this YAG. And doping concentration, how we are mixing this ND means ND and YAG. The doping concentration, that is approximately that is equal to 0.72 percentage of weight of corresponds to 1.4 into 10 to the power of 26 atoms per meters cube. And the rod, whatever the rod we are using, ND YAG rod we are using, the diameter, the length of the particular rod that is 10 centimeters, and the diameter of the particular rod is 12 millimeters. Okay, and NDR rod is a linear flash lamp housed in an elliptical cavity. Okay, it is parallel external mirrors. There are two mirrors are there, and parallelly silver coated and fully silver coated system. It is the NDR laser. We can place in the coolant form. Okay, now coming to the construction. Here the NDR laser Here the NDR laser, that is consisting of, first of all, that is NDR rod. In this NDR rod, the concentration of the neodymium atoms are more than yttrium aluminum garnet atoms. Okay, na? Here that is in the, this is NDR rod. Now here, and one flash tube is there, that is the xenon flash tube is there. The xenon flash tube and NDR rods are, we can place perpendicular to each other. Okay, now we can place sorry, parallel to each other. Okay, now here elliptical reflector, two elliptical reflector, we can place two elliptical reflector at the each side of this elliptical reflector, we can place in the neodymium and flash tube, and two mirrors are there, that is fully reflected mirror, this is partially reflected mirror, and this total arrangement we can place elliptical, we can place in one cavity, one reflecting medium. Okay, na? And reflecting medium. Now we require power supply, and for the power supply purpose we are using this arrangement, and this is the capacitor charging and discharging of, by using this charging and discharging we can we can say that either we are getting the particular output of the beam or not, laser beam or not. Okay, then this is the trigger pulse. This is the trigger pulse we are using in Q switching application. Okay, now coming to the application, operation, this is the construction. Coming to the operation, when we are giving a power supply to this flash tube, when we are giving a power supply to this flash tube, xenon flash tube, due to the due to that, here this flash tube, it can emit this some radiation. Due to that emission of this radiation, this neodymium YAG rod atoms are excited. Okay, na? This neodymium YAG rod atoms are excited. Here this, when the atoms are excited over the threshold value, when it is over the threshold value, it will goes to the, here when we are giving the power supply, here it will emit some emit some light energy, light reflection. That reflection, that will goes to the NDYAG rod. Due to that, here the ND atoms and YAG atom, it moves from the one direction, one end to the another end of this rod. Here when it is reaches the over the threshold value, out of the threshold value, the here some atoms that will goes from the here out of this from the this partially reflected mirror. Okay, na? Partially reflected mirror. Now then we are getting some output. Okay, getting some output. Now here this is how energy levels of ND ions in a crystal, particular crystal. First of all, initially when the light energy is when the flashes light is there, we are getting, due to the flashes lighting, here ND ions are moves from the one end to the another end of this rod. Okay, now next, here this optical pumping, where initially at the there are NDYAG laser is a 4-level laser. 4-level laser, initially the atoms are is in energy level 1. Due to pumping action, whenever we are pumping, that is optical, the pumping action we are required here. What is the type of the pumping? The optical pumping is required in this NDYAG laser. Due to that optical pumping, the ions can move from the energy level ground state to the energy level 4, higher level higher level, within the range of, from the range of optical pumping, the range of 800 nanometers and 700 nanometers. Okay, na? 700 and 800 nanometers. Here when the atoms are reaches the higher level, it can stay, some atoms are that is reaches more energy level than the E4, it will reaches the another energy level, that is E4 dash. Okay na? It will stay some less amount of the time here at the higher level, less amount of the time in higher level. After here, the atoms, the ions are falling down from the E4 E dash 4 to E dash 4 to E3 and E4 to E3. Okay na? Here there is no here what is this? There is no here the ions are not reaches not stays more time here in energy level 4. Okay na? Due to the spontaneous emissions, the spontaneous emission is there in the energy level from the E3 to E4 to E3. Okay na? Due to the spontaneous emission, the ions are it can falls down from the E4 to E3. Okay. Here, when it can falls down the E4 to E3, the ions are, it can stays in energy level E3. Here, it can stay some time as compared to the more than this one, more than time of this one E4 and E4 dash. Okay, na? The atoms can stay more time. Here, at this stage, E3 greater than E2. E3 is greater than E2. At this place, there is population inversion is achieved. In this place only, there is population inversion is achieved. Due to the population inversion, the ions are falls down from the E3 to E2. Here, when the population inversions are going on there, here the laser light is, we are getting some laser light beam output with the range, with the frequency, with the wavelength of 1.006 micrometers. Okay na? If it is the density of the particular ions are very less density, the ions are, it will directly comes from the E3 to E1. Okay na? If it is the depending on the density of the particular ions, we get the some emission. That emission is nothing but laser light. Okay na? That is pulsed or continuous light output we are getting here. Okay na? This is about energy levels from E2 to E1. Then again the ions are we are passed down from the E3 energy level 2 to energy level E1. Now this is about Individualizer. It is a four level laser. It requires pump, lower pump energy and terminal laser level sufficiently far from ground state. Always the E3 state, wherever the E3 state is there, here this is the E3 state, this is the metastable state. In this metastable state only the ions, the number of the ions are more than E3 to E2. Then only the population inversion we are achieved. Okay, the population inversion is we are achieved. Now the metastable state. The lifetime of the metastable state, the atoms stay at the energy level 3 is 230 microseconds. Okay, and two pumping bands are there. Two pumping bands here. This is one pumping band. This is one pumping band. The pumping band at 800 nanometers. The pumping band second one is 700 nanometers. Two pumping bands and pump intense xenon lamp. There, this is xenon lamp. Flash tube is nothing but intense xenon lamp. Now ND3 ions level E4 decays to upper level at E3. Upper level laser at E3. Population inversion easily achieved between E3 to E3 to E2 levels and stimulated to emit 1064 nanometer laser transition from energy level E2 from E2 level to neodymium ions quickly drop to E1 by transferring energy to crystal. Okay. Now many other transition in near IR region. The range of the emission is we are getting some laser beam output within the range of infrared region only. We are getting output laser beam in infrared region. All weaker than 1064 nanometers. Okay, na? Only 1318 nanometer transition produce 20% of power as that of the 1064 nanometers. Okay, It useful in fiber optic transmission. Laser output. The laser output we are getting either via continuous output or the pulsed output. Okay, pulsed output. The efficiency is equal to 0.1 to 1% of range. Xenon lamp, flash lamp, pulsed output we are using the term. The pulsed output we are getting when we are xenon flash lamp we are using on the for the xenon flash lamp when we are using xenon flash lamp, the output of the laser is pulsed output. The tungsten hydal incandescent lamps when we are using continuous output we are getting. Continuous output power of over where the output is 1 kilowatts of output we are getting. Can be pumped by the diode laser for high efficiency. Diode laser for high efficiency. This is about ND YAG laser. Now I am going to ND glass laser. Now ND glass laser, instead of ND YAG, that is the crystal, instead of now I can place ND glass also. By using that glass also, now I am getting some high output power. High output. Why? Because of the glass that is high pulsed operation, and here it is when we are using ND glass, the output of the particular laser we are getting only pulsed output. Why? Because of they are having the glass that is having very large size, flexibility and physical parameters, and the broadening fluorescent lines and different other properties also we are getting some only pulsed output. Okay, can deliver much higher energies. Can deliver much higher energies. Can be doped at very high concentration with excellent uniformity. And one more main advantage of this ND glass laser is the output power, whatever 1 kilowatts of the power only we are getting in ND YAG laser, coming to here more than 1 kilowatts of the output power we are getting in ND glass laser. And practical limiting is determined by the fact that the fluorescent lifetime, and therefore the efficiency of the stimulated emission decreases with the higher concentrations. Okay, higher concentration, and can be in a variety of shapes and sizes. Due to the different types of shapes and sizes from the fibers few micrometers to diameter to the rods of 2 meters long as to 7.5 centimeters of diameters, and discs up to 90 centimeters in diameters and 5 centimeters thick of particular rod. And the major disadvantages of the glass is a low thermal conductivity. As compared to the previous one, it have very less thermal conductivity. Okay, and glass, an excellent host material in for neodymium. As compared to that YAG, it is a glass is excellent material for neodymium. Attraction for the glass. It can well develop technology for making large size glasses with good optical quality. While ND-YAG lasers can be operated in continuous mode, ND glass lasers can be operated on only pulsed mode. Okay, na? And ND glass lasers we are getting some output power is more. High energy short pulses can be heat matter to thermonuclear temperature, thus generating energy in small controlled explosion. And coming to the advantages of ND neodymium based lasers. These neodymium based lasers are no chance of wasting of material, because here the medium, whatever the active medium materials we are using, either that is gas or the crystal we are using, that is solid state. There is no wastage of material is there, and both continuous and pulsed output we are getting, and construction is simply as compared to the ruby laser, and output power ranging from a very low value about 0.04 watts to high value of 600 watts we are getting output, and cost of solid state lasers is very economical. Coming to disadvantages, efficiency of solid state lasers is very low as compared to carbon dioxide lasers, as compared to the next one, gas lasers are there. Now when I am going to the next laser, there is a carbon dioxide gas lasers. The under gas laser, one type of the laser is carbon dioxide laser. Great disadvantage of solid state lasers is in the divergence, which is not constant and range 1 milliradian to 20 milliradian, and output power is also not very much as carbon dioxide laser. Due to the thermal lossing, in solid state laser, the power loss occurs when the rod gets too hot. Okay, na? And application. NDYAG lasers, solid state, that is a solid state laser, are used in drilling holes, drilling purpose we are using. ND-YAG laser pulsed type solid state lasers can be used in medical applications such as endoscopy application. In military navigation and target identification purpose we are using this ND-YAG lasers. And ND-YAG lasers based application is, that is in drilling purpose and soldering purpose we are using this NDR lasers. With this, neodymium based lasers are completed. In the next session, now I am going to the gas lasers. Okay, thank you.